then I want you to recall the definition of an even function. So if we have an even function, you know, let's use the notation y equals f of the input would be x here traditionally. Okay, this x and this y just represent x input, y output, not the same x and y as the length of the sides of a triangle, right? F is called an even function if you input the opposite of x. You know, for any x value, you can input the opposite of it, f of negative x, and you get the same thing you would get if you input x. F of negative x is equal to f of x. So that's an even function. A traditional example, an easy example of an even function would be something like y equals x squared, or if you like, f of x equals x squared, which graphs to be a parabola that's symmetric about the y-axis. So you can see that if you input a number like 2, what does 2 go to? 2, okay, you plug in 2, 2 squared is 4. So it goes to 4. So up here on the graph, this would correspond with a height of 4, right? But certainly if you plug in negative 2, it's also going to go up and have the same output, if you make the point big enough, as its opposite input 2. And so even functions, when you graph them, have that characteristic that they're symmetric to the y-axis. If you folded the graph across the y-axis, the two halves would touch. And then for an odd function, f of negative x turns out to be the opposite of f of x. And the classic example there is y equals x cubed. There's other examples, don't get the wrong idea, but these are just the easiest examples I can think of. And you can kind of see where the name comes from, the exponent's odd. One feature of an odd function, if you have a point xy on the graph, then automatically negative x, negative y is on the graph. That's what really this translates to. Point-wise, negative x, negative y. So that if you rotate the graph about the origin, 0, 0, 180 degrees, you get the same picture. You get the same picture. So even function f of negative x equals f of x. Odd function f of negative x equals the opposite of f of x. So why do I mention that here? Well, it turns out that your trig functions, your 6 trig functions, are either even or odd. And here's the easiest way to remember it. Cosine's even, which means it's reciprocal. What's its reciprocal or related function? Secant, right? Secant's 1 over cosine, or cosine's 1 over secant, is even. So cosine and secant even, the rest are odd. So if you can just remember cosine's even, you're golden. Couple of real quick simple examples of what that means. So that means if you take the cosine of negative t, then that's the same as taking the cosine of t. You can assume this is true. You can use this property, okay? Cosine of negative t is equal to the cosine of t. But the sine of negative t, what would that be equal to? That would be equal to, it's like you're pulling the negative out front. Negative sine of t. Sine of negative t is equal to the opposite of the sine of t. So these are properties we're going to make use of. You can use these, assume they're true. I'll show you one of them is true, but you can assume that they're true. I'll show you how to verify that they're true. In this example, is the function even, odd, or neither? Notice what I did. I made the input x. This x has nothing to do with the x from the right triangle we've been drawing, or the x from the output of the wrapping function. It's just, we usually switch from t's to x's eventually. I don't know why, that's just x is a standard input. Okay, so here x just represents a generic real number. Think of it that way. And we're going to use what we know about whether or not the sine, cosine are, whether or not they're even or odd, in this case, whether or not the cosine's even or odd. We're going to use what we know, and we're going to use the definition of even and odd function to tell whether or not this new function we've created is even or odd, or neither. It doesn't have to be either one. So think about it. The test to see if a function is even or odd, you start out the same way. You go like this. You plug in negative x for x. So that's just saying, hey, make all the inputs in your formula negative x instead of x. That's what that notation means. So how does this formula change? We have cosine of x divided by x. What do we end up taking the cosine of? Now, notice there's no parentheses around the x to start with. When you plug in something like negative x, the convention is to go ahead and insert those parentheses. So that's the input of what happens to the numerator when we input negative x, and then the denominator becomes negative x as well. No parentheses necessary there because the division bar is a grouping symbol, you guys. So what do we want to look for? We want to look to see if the negative goes away and we get the original function back again. In that case, it's an even function. Or if we get the opposite of the original function back again, it's an odd function. That's what this says. If you input negative x and you get the original formula back again, it's an even function. If you input negative x and get the opposite of the original formula back again, if you factor out the negative if necessary, then it's an odd function in that case. So that's what we're checking in case I didn't make that clear enough. Now, we know cosine's even, right? So what happens to this negative right here? It cancels, so you get just cosine of x on top. Okay, canceling isn't quite the right word. It's the reason we can do that is because cosine is even. So this, and then over negative x. So the reason this equality happens is you can assume cosine is even. That's what an even function does. Cosine of negative x is equal to the cosine of x. This negative didn't go anywhere. Can I pull that out front? I can't. Think about it. 2 divided by negative 3 is the same as the opposite of 2/3, isn't it? You can pull that negative in the denominator out in front. Okay. So I get the opposite of the cosine of x over x. What do you notice about the thing that comes after the negative symbol here, the opposite? What is this exactly the same as? The original function. This is the opposite of the original function f of x. So follow the equal signs. We just showed that f of negative x is equal to the opposite of f of x. What kind of function is that function? It's odd. When that happens, when f of negative x equals the opposite of f of x, you've got yourself an odd function. F is odd. Follow this argument. Does that make sense? F of negative x equals the opposite of f of x? Then you need to know when that happens, f is odd. When you can pull the negative out front, f is odd.